Greetings and welcome, friends. Mr. Waddy here and my geometry students. And we're going over last night's homework. Man, they're gonna think I'm like super passive aggressive towards you guys. They're not gonna know why. Like why? So. But anyways, here's question 4. We were talking about reflections. What do you guys think about question 4 here? It says determine whether the coordinate plane shows a reflection in the x, y, or neither axes. Sort of transformations going on here. No? Is it a reflection? It looks like a translation. So their answer is neither. Is it possible I could have accomplished this using multiple reflections? Or yeah, your own custom spots, you know. Yeah, let me see. Am I able to reverse this? No, I can. Yeah, that's sad. Doesn't that make you guys sad? I can rotate it. Let's see. I just want to think this out. If I reflect over the y, I would land here. Okay, reflect. Sure, down the line, x equals 1.5. Okay, and then what would I have to do? Reflect across the x, so that would be this, this, this. Y equals this line. That would map it back on. Yeah. All right, so yeah, it looks like there's a way I could do a series of reflections and eventually get myself there, but that's weird. The correct answer to that problem was neither. Neither. That's how you pronounce that, too. Have you guys ever watched YouTube videos about how to pronounce words? They're like super short videos, but they teach you how to pronounce a single word. Yeah. Graph triangle Jekyll, and its image after reflection in the given line. So let's see. J is at 1, down 1. There's J. K is at over 3, up 0. K. And L is at 0, negative 4. There's L. You could imagine a triangle there if I drew well. And I'm going to reflect it over the line x equals 2. What does that line look like? It's a vertical line that passes through 2 on the x-axis. What is the slope of that line? Undefined is correct. All right, and so when I want to reflect, remember we measure perpendicular to the reflecting line there and the same distance away. So here is going to be J prime. K prime was 1 unit away, so 1 unit away over here is K prime. And L is 2 units away, so 2 units away over here would be L prime. And this triangle actually ends up getting mapped onto itself, overlapping in spots. And for those points in particular, I missed terribly, but they would have been the points that were mapped onto themselves in respect to the triangle. All right, how about the line y equals x? Where's that? What's that look like? Yeah, y-intercept is 0, slope is 1, so up 1 over 1, up 1 over 1. Yeah. Maybe. Like a 45-degree line there. Wait a minute. What am I doing? I need it on. Yeah, that's right. That's right. That's better. Nope. Also not. Here it is. That looks real. I was looking at points far away to try to get a better line, and then it was giving me a hard time. So let's see. B. Well, I guess I'll start with A. A is 1.5 diagonal units away from the line perpendicular to it, so 1.5 units. Actually, A is going to be mapped right onto where old B was, and I'm guessing the same thing will happen to B, so B prime is going to be where A was. Charlie is half a diagonal line from the perpendicular there, and so Charlie prime is going to be right here. And delta is 1 diagonal away, so 1 diagonal away, opposite side will be delta. Something like that. Be this figure, which is looks just like some sort of quadrilateral. Nothing special about it that I can tell. All right. Ooh, I pre-drew my my pre-image. Pre-drew the pre-image. So what do we call this when we translate and then reflect? A glide reflection. That's right. So let's see. Looks like I'm gonna add 2 to the coordinates, both x and y respectively. So over 2 up 2 will be t prime. Over 2 up 2 will be s prime, and over 2 up 2 will be r prime. So something like that. Do an idea. And my glide reflection is in the line y equals x. That's still 45. Look at that. That's still 45. Thanks. All right, so let's reflect again. This is 1.5 away, so 1.5 away over here. Now r double prime. T is 1 diagonal away, so 1 diagonal away over there. T double prime. And S is 2 diagonals away, so 2 diagonals away over there. S double prime. Something to that effect. You also could have done it using a series of coordinates and some of those points translation rules that we had with respect to like flipping the coordinates or changing their signs. Actually, in this case, do you guys remember what happens? What's the rule for a reflection in the line y equals x? Any x, y becomes what? Yeah, y, x. That's right. I only said that because that's the other ones I have to think about a little bit. Yeah, so here's this point at t prime, which was like 8, 6. And notice t double prime is now at 6, 8. So that does, in fact, verify. Ooh, lines of symmetry. What are your guys' thoughts? 0? Let's see if I can get this. All right. Not rotate that. I think I should. Do you guys agree that even if I tried to reflect over here, that doesn't work. That doesn't work. My little menu. I thought I had a whole like little up. Oh, I saw. Oh, like symmetry this way or this. Ooh, I could try both ways. Whoa, crazy. I undo that other symmetry. Yeah, here we go. Yeah, just to verify that it doesn't work, right? If I trace this half, that's not the same thing. That doesn't work. And if you suspect that the diagonals work, which sadly my tool is letting me rotate, I guess I'd have to rotate the that's crazy. That won't work as well. So the answer, I agree, was none. Zero. The lines of symmetry are lines that if I mirrored a figure over it, it would map the figure back onto it. Looks like I'm all done. Ooh, do I have any other cool? Guess not. Well, anyways, thanks for watching.